This presentation of SolidWorks will be dealing with simulation a little, and also with a new product called Design Study in SolidWorks. You recognize the tank from the weldments that we did where we built the platform under the tank. Well, now I'm going to go in and actually edit that platform. And the first thing I want to do is I want to place a weight or a pressure on the areas where these pedestal feet are sitting. And I'm going to go in and do that using split face functionality. I'm going to right click and select loop, do a convert entities to accept that. And then do the same thing on the other foot. Select the foot and do convert entities, and now that I've got the exact places where those feet are touching the platform, I can get out of that sketch now and go ahead and edit my component. Now I'm going to open that part, and as you can see, the sketch came along with it. And we're going to go real quick into features and curves and split line and tell it that I want to use the sketch 15 to split the face of the top of that platform. And as you can see, if I select the top, now we've got each one of those components are separate. So now we can make a true study of this part. So let's go ahead and get into simulation. I've already got it added in. We're just going to do a new study. This is going to be a static study. We're just going to leave it at that name. The first thing we want to make sure of is to make sure that all the materials have been applied. And you can see here we've got some solids and we got mostly beams here, and that's fine. We want to make sure that our joint groups have been defined. Looks like all the joints are there. So we go ahead and click calculate and tell it OK. And OK, letting us know that it's been taken care of. Go to our connections, do a contact set. And we want to do a bonded contact set, and we want to do it between the beams, on the bottom, on all four sides, and also across the middle with the bottom of that plate. We'll make sure that there's a contact there between those items. And then finally, with the fixtures, we want to go in and make the fixtures fixed, and we'll just use the joints that we've got at the end of these legs. These are going to be sitting on the floor, so they're not going to be moving around. So we can say that those are fixed components. And then finally we're going to do a force. And this force is going to be specifically where those feet were sitting on my platform. We're going to change this to English, and we're going to tell it that it's going to be 4,000 pounds per foot. And we're going to leave it at that. And I'm just going to go in and create the mesh to run it. It takes just a few seconds to run the mesh. Now what it's doing is breaking down each individual part into small triangular elements that allows it to calculate the results of this. And as you can see there, we actually have beam elements, which are along the beams, and we have the triangular elements, which is along the solids. Now we can tell it also now to go ahead and run. Right click and run. SolidWorks is taking this through the analysis process of each one of those separate beams until it gets to a result. And there we see the result of the plate on the top. We want to change that to the beams. We want to see what that is. So we're going to change this to PSI. And I want to just see the automatic scale of it. Click OK. And you can see there that we have some deformation. But we're only at 8679 psi, and that's well below the yield pressure or yield strength of this particular material. Let's take a look at the displacement now, and you'll see that this displacement is actually in millimeters, which we can change, edit definition, and we can tell it that we want that in inches, and just give me an automatic shape of it. So you can see there how that deformation is happening. We can also go in here and do an animate and show you how that force is being applied to this particular part. And you can see there, SolidWorks applies that force a little at a time, but here we see that the forces are complete. Now, this is basically telling us that there's 1.396 inches of deformation in this part, which is a great deal of deformation. So we're knowing that our center bar there is not in the right location. So what we need to do is we need to create a study from this study, which is called a new design study, and we're going to go in and we're going to tell it what the variables are. And we already have a variable listed. If we go into add parameters, it brings up a box and it allows you to set up different parameters, select the model dimensions and your mesh and other things here to apply it to it. We've already got a crossover in there, so we click cancel there, and we're just going to drop this down and pick the crossover. Now my crossover location is actually the dimension between the end of this and this beam. So we want that starting dimension to be 64, which is the way it's set up now. If we zoom in on this, you see there that it's 64. And we want to say, let's go to 120 inches here. And we want this to be in 12-inch steps. So what we're going to do is we're going to go from 64 inches to 120 inches, moving this beam across this table until we get to the appropriate level that we're looking for, the way we're set up the rest of our parameters. If I go in here and add a sensor, I can add that sensor simply by going in here and telling it that I want to use that as simulation data. I want to use the stress, and I want to be in English, so PSI, and I can use factor of safety and everything as well. If I click there, really the stress is not a factor here, so we can actually delete that one out. If I click here to add a sensor, let's go ahead and do it one more time. This time let's add a deformation sensor, a displacement sensor, and we're going to use the resultant displacement, and that's already in inches. So my resultant displacement, I want it to be less than 3/4 of an inch. Right now it's a little over 1.25 inches. So we're going to say we want it to be at least less than 3/4 of an inch. Anything under that we can accept. Now we can also put goals here, and the goals may be that we use a stress goal and tell it that we want to minimize the stress in this particular study. We can also tell it, add another one and tell it that we want to reduce the displacement, which we do. So that's two different goals that we're setting for ourselves here in this particular study, and we're just going to tell it to run. Now what SOLIDWORKS is going to do is it's going to start off and it's going to go through the design scenarios that we've got set up, the 64 to 120 inches in 12-inch increments. It's going to run those, and as it runs them, it's going to give us a view of what those results are. You see there that we have the initials, the current, and the initial running. If you'll notice that as it goes through this, that it actually moves this beam over in 12-inch increments, 64 to 76 to 88 to 100, 112, and 120. It's going to run it through each one of these scenarios until it finds the right one that meets our criteria. So as you can see, the results of our study has not been the 67, the 64, the 76, the 88. Not until it got to the 100 did it find a suitable scenario. And there we went from having 19,587 psi worth of stress down to 10,429. Actually, the lowest point of stress was in scenario 5, which was 9275. The lowest point of displacement being in scenario 4, which was a 0.64538. Even though there was less stress on scenario 5, the displacement was just a little bit greater. So we actually have 3 scenarios there to choose from, and we can actually go through and pick these scenarios and have that beam move to those particular places and look at it. According to the software, the optimal is 112 inches. So at that point is where the beam needs to be located in order to meet all the criteria that we have and give us the best possibility of meeting that criteria of keeping the stress down and the displacement down as well.